All right, guys, this is the video for the second part of probability. It's called random variables. Okay, and so that happens when we have unknown possibilities for things, such as we're not sure the average weight of people on the plane. Okay, it could vary this much, and then we don't know the average weight of their luggage. It could vary this much, and so it's important airplane wise to note how much, okay, so overall, what do we think we're talking about when we want to combine these weights together, and what variability do we have with those combined weights? Okay, so this is called random variables. Now we're talking discrete, meaning, then we also have the discrete ones where there's set number of items. And we'll talk about those first, and then we'll talk about the combining and transforming. Now, I want to first draw your attention to the formula chart. And what it has here is you can get this, and of course we've talked in the previous video on these top two items. FYI, in AP Classroom, Unit 4's multiple choice section B is centered around these random variables, okay? But discrete random variables is typically where we have, that set number of outcomes, just a finite number of possibilities, and they each have those probabilities. So we've got the mean, the expected number, and then how much it varies. So I've got you an example here. Here is the household size from the U.S. Census 2010. And so, see, it's discrete in that they defined it in these certain number of categories. We've got these 7 categories, finite amount of possibilities. 1 person in the household, 2 in the household, 3, 4, 5, 6, or 7 or more. So then they put those probabilities, and so the frequency at which those happen. So then if I was to say, oh, okay, on average, how many people live in a house in 2010, then I would get the mean. And so then I would be doing that, by putting the events in list 1 and their frequency, their probabilities in list 2. And then I would be computing the one variable statistics of list 1 with list 2's frequency. Now, if you have a calculator that is older and it doesn't have the updated operating system, then when you put that into your calculator, you would do the one variable stats of list 1. Let me see if this pulls up here. You would do the second second stat. Sorry, still wrong. Stat over to calc, one variable stats of list 1 with list 2's frequency. But if you don't have this menu that shows up, then you have got to put it into your calculator like this. You've got to go where you end up typing it one variable stats. You put in one variable stats, and then you have to type of L1, comma, L2. It's very important. L1, comma, L2. If you leave off this part here, the comma L2, then all it's going to do is just do the average of L1. And that's just going to be the average of those numbers there. Okay? I guess when they computed this or whatever, they just put the 7 into that 7 or more. That's weird. Okay, but anyway, so there's that. So, of course, we expect there to be about 2.5. And then, here is the standard deviation. Now, notice it is the population standard deviation. And the reason it is the population standard deviation is because these frequencies total up to 100% of the frequencies. That means those numbers are the entire population. Okay, so that's why it's that and not the sample standard deviation. Okay, so that's the expected value. Expected value is the mean. Expected value is the mean. Now, let's talk about that combining and transforming. So I have this here, but then I also have some thinking maps that do use even these same problems, okay? So I'll show you that, and then you can choose which format you like. If you just like going through the notes like this, or if you want to have a shortcut sheet on the thinking maps. All right. So when we're combining and transforming, again, we need to keep in mind that the mean, they're good to go. They will add and subtract, multiply and divide, combine, just as you would normally expect them to. That measure of center moves around and changes just like we would expect it to. But that standard deviation, that special standard deviation, has special rules. Always. Special rules. Well, so here's the thing. If you are adding standard deviations together, you can't just add them together. You have to go through that Pythagorean theorem of statistics. So one of them squared plus the other one squared, and then take the square root. You're adding the variances of them. Remember, variance is the standard deviation squared. So one squared plus the other squared, adding their variances, and then square rooting it back off. If you had three things you're adding together, you're combining. Three weights classifications you're combining. Square the variance of the first standard deviation plus the variance of the second one plus the variance of the third one. So this squared plus this squared plus this squared, square root it. Okay? Now, the other thing is that, your standard deviation never gets smaller. So you are never, even if the means are subtracting, even if we're talking about how much cereal is left in the box. Well, I'm not sure what's in the box of cereal, how much weight exactly. Then I'm going to pour out a bowl. Well, I'm not exactly sure how much I poured out of the box. So I wasn't sure what was in the box. I'm not sure what I poured out of the box. So I am even more unsure of what is left in the box. So even if my means subtracted to show me what's left in the box, the uncertainty and variability gets bigger. Okay? All right, so let's take a look. The best way to do this is just to go through examples. Okay, so I'm just going to have to take you through those. So here we go. We want to combine. Okay, so here I have 25 regular M&Ms and then 25 Halloween M&Ms for each package of those. They're the little mini packages. We got the regular kind and the Halloween kind. Okay, well, what you get in the bag of M&Ms varies. Okay, there's usually 6 orange on average, but we have this standard deviation of 2. Okay, the Halloween ones, there's usually about 11.25 orange, because those ones just have orange, green, brown, and purple, with a standard deviation of 2.49. Okay, so we have those 2 uncertainties with how many M&Ms there are. All right, so we're going to add, so the means going to add or subtract like normal. Okay, so if I wanted to say, on average, how many orange do you expect in one bag of each? You would just say 6 plus 11.25. Okay? But I'm just adding a level of difficulty. How much do you expect in 3 packages of regular and 2 packages of Halloween? You went trick-or-treating and that's what you got. So then they just add like normal. I've got 3 of the 6s plus 2 of the 11.25s. So on average, I've probably gotten 40.5 M&Ms. And remember, those can be a decimal because this is on average. All right. You may also see it, of course, as 3 of the 6s plus 2 of the 11.25s. Now, standard deviation, however, is tricky. All right, Pythagorean theorem, and it always adds. So look, you hear what I got. So technically, here's what's happening. We've got these variances here. The 3 standard deviation squareds for the regular M&Ms and the 2 standard deviations squared for the Halloween M&Ms. So I'm combining all those 5 together and then square rooting it. You also could see it like this written. 3 of the regular M&M standard deviations plus 2 of the Halloween package standard deviations and then square root it. So there is my variability. So I expect when I come home with 3 bags of regular and 2 bags of Halloween, I'm going to have about 40.5 M&Ms, orange ones with this variability. All right, next. So what if I'm talking about a certain number of items per Lucky Charms and per box of cereal and a certain number of items per box of Life cereal? So this is items per section. Okay? So let's take a look at this situation. There are 14 boxes of Lucky Charms cereal sold per day on average, with 3.5 boxes. So this is a per day boxes sold. 18 boxes of Life cereal sold per day on average and a standard deviation of 4.5. Okay, so let's transform those means. They're affected by add, subtract, multiply, and divide as we normally expect them to. So here is the question. What happens if the profit per box of Lucky Charms is 0.65 and the profit per box of Life is 0.72? So that's a 65 cents per Lucky Charms amount and 72 cents per Life cereal box. What's the expected profit that the grocery store is going to get for these 2 products? So we're going to transform them from the number of boxes. I guess this would mean on any given day, on one day. So we're going to transform this from how many boxes you sell in a day to how much profit you make in a day. So we transformed units from number of boxes in a day to how much profit in a day. All right, so on average, our profit for the Lucky Charms is going to be $9.01 because we have 65 cents per 14 boxes in a day, and then the Life, 72 cents per 18 boxes. So on average, so we want to transform first and then combine. Okay, so if you're changing units, transform first and then combine. So now I can combine those together and I get my profit. All right, but let's take a look at how this looks with standard deviation. The reason I kind of have to take you through this transform first and then combine idea is because then it will help you with this standard deviation situation. All right. We know standard deviations are only affected by multiplication and division. Okay? So transform first and then combine. So here we go. We're going to recall that our standard deviation for those profits, let's see here, is 3.5. Number of boxes sold in a day. Standard deviation is 3.5 boxes of the Lucky Charms and 4.5 of the Life. So here we go. Transform first and then combine. So here I have now the variability of the Lucky Charms profit. How much is your profit per day going to vary on Lucky Charms? How much is your profit per day going to vary for the Life cereal? See, 65 cents for this boxes sold standard deviation, 72 cents for the boxes of Life standard deviation. So now I will combine. First transformed and then combine. So I have that variability of the profit for Lucky Charms squared plus the variability for the Life cereal squared and then square root it. All right. So here we have one that's even more complex. So where we have not just this multiplication component, but a daily bonus. So I have an additional amount. Okay. You know, and this is happening, the General Mills will give the grocery store a daily bonus of $3 for every day that they put those Lucky Charms displayed on the end caps, the ends of the aisles, because they know if it's on the end of the aisle, it's more likely to be chosen because you got another aisle, somebody walking by is going to pick it up. All right. So General Mills gives a daily bonus of $3 for their Lucky Charms. Quaker Oats gives a daily bonus of $2 for the Life. So see, here is now this transformation. For Lucky Charms, it's 65 cents per box plus $3 for the profit. And Life is 72 cents per box plus $2. So then we ask, okay, how is that mean and standard deviation affected? So transform first and then combine. So we're going to do that here. Look at my mean is affected by the plus 3. So that is on average then 12.1 per day that I have them displayed on the end caps. Okay, and then here is that Life one. So the mean profit is affected by that amount that you are on the end caps. So you're taking that and shifting it up. All right, so then the total, then you combine. First transform, then combine. Okay? Now, but here is the deal for our standard deviations. First transform, then combine. Well, is spread affected by adding $3 or adding $2 for being on the end cap? And that answer is no. Measures of spread are only affected by adding and multiplication and division, not adding and subtracting. So see, look at there. Therefore, that profit variability remained the same as before. We discussed that $3 bonus and that $2 bonus. So notice, no adding or subtracting change. Therefore, that standard deviation variability, that variability of the profit was the same as what we saw before down here with this one here. So the variability is still the same way as before we talked about the $3 and $2 bonus. All right. So I have got those situations also shown here on this thinking map. It just kind of takes you, see, look, it takes you through the exact same problem, but it's just in a different format. Okay, so we've got those means combined, but then the standard deviations. See, we had that separate, okay? And then here was the Life serial. See, those means combined, but then those standard deviations, transform it first. See, transform it first from boxes into profit and then combine. Okay, and then here was the situation where we had the end caps with the plus $3 and the plus $2. That measure of spread was not affected. Okay, so that is just a summary of the notes in thinking map format for easy reference. All right, and so then I'll attach those also to this Canvas notes page. Now, the random variables here then are going to be on the multiple choice section part B. Okay, so after you've watched this video, then you would be better prepared to do multiple choice section part B in Unit 4 on AP Classroom. Okay, so I hope that this helped you remember all of this stuff about random variables.